Okay, so we're going to go over some fraction rules, okay? This one we're going to go over multiplying fractions to start. Do you remember what we would do from here for multiplying fractions? Do you remember your rules?
4 times 2 and 4 times 3.
You're thinking cross multiply, but that is when they're equal to each other. This one says multiplied by. So whenever you multiply fractions, we're actually multiplying the top by each other and the bottom by each other. So the numerators times the numerators and the denominators times the denominators, okay? So in other words, you can kind of look at it like this, okay? You can kind of look at it where we have 2 times 3 over 4 times 4. I can just draw one straight line underneath, okay? And then we can go to equals. So what is our 2 times 3 going to be?
6.
That's right. And 4 times 4?
16.
That's right. Now the only other thing is they probably want us to put this in lowest terms. So what can I divide that to make that fraction lowest terms?
3 over 8.
Yeah, if we divide both by 2, right? That's good. We would get 3 over 8. Okay? So that would be the lowest form of this. So what we're going to do is we're going to make a little sheet on the side with fraction rules. And we're going to do that in a minute, okay?
Mm-hmm.
So what I want you to do is, now I've showed you that rule, I'm going to make up a question. So let's say we have 6 over 8 times 3 over 2. How do I go about solving this?
6 times 3.
Yeah, so we use 6 times 3, which is what?
18.
Okay. And then what?
16. 8 times 2.
8 times 2, good. Or 16. And if we always want it in the lowest common denominator, we want our lowest form fraction. Are they both even numbers?
Yeah.
So what can go into an even number?
2.
2 always goes into even numbers. Okay. So then what will we get?
9 over 8.
Good. That's it. That's its lowest term. So that's multiplying fractions. Seem easy enough? Okay. Multiplying fractions is probably the easiest thing you'll do with fractions. We'll do the next page, which will be dividing them. All right. So we put up our multiplying fractions rule over here. Next thing we're going to do is dividing fractions. Okay. So we're going to use the same numbers I've used in my multiplying fractions. We'll use the same question. We have 2 over 3 divided by 5 over 7. So we're dividing by a fraction in this case, okay? Now, they teach you a trick with this. They tell you to invert and multiply. And what that means is you're going to flip this fraction, and you're going to change this to a multiplication sign, okay? So we put equals here, and then we get 2 over 3, keep that the same. This becomes multiplication, okay? And instead the 7 is on top and the 5's on the bottom. So now it's a multiplication question. With our multiplication questions, we already know the rules. We already learned them, right? I can change that multiplication question. I only multiply the top numbers by each other and the bottom numbers by each other. So we'll end up doing 2 times 7 and 3 times 5. So we're going to get 14 over 15. So the answer to this, 2 over 3 divided by 5 over 7, is 14 over 15. Okay, I'll write it right here for you. So put the answer there. Does that idea make sense?
Mm-hmm.
So we got to do that each time we go to divide a fraction. So I'm going to make up a question again.
I wouldn't have remembered that.
Yeah, so this is a rule you got to remember because you're going to run into fractions for sure that you're going to have to work with, okay?
Mm-hmm.
So let's make up example 2, let's call it. Here's example 1. Example 2. Oops. Okay. Let's say we have 4 over 8 divided by 9 over 7. So a little bit harder to deal with. What do I have to do in this question? Walk me through this.
Flip everything.
Everything? So I flip both fractions?
No.
No? What do I do?
9 over 7.
Okay, so yeah, we're going to flip it. Okay. And then what do I do with the division sign?
Multiply.
That's right, it's going to turn into a multiplication sign. So what's this going to look like now?
7 over 9. 4 over 8 divided by 7 over 9.
Divide it by 7 over 9?
Multiply.
Ah, good. We have to make sure we change the sign, otherwise everything goes haywire. Okay?
Mm-hmm.
So now when we multiply that, what do we get? What's 4 times 7?
28.
Mm-hmm. And 8 times 9.
Wait. 72.
Mm-hmm. Good. Now we can reduce this, but essentially that's your answer, right? We can reduce this fraction. Are they both even numbers?
Are they both even? Yeah.
Mm-hmm. So what can we divide by for sure then?
2.
So we can divide both by 2. Let's see if we can reduce it even farther. So 28 divided by 2 gives us
14.
Yeah. 72 divided by 2.
Maybe a decimal.
No. 72 divided by 2, 36. So I have even numbers again?
Divide by 2 again.
Yeah, that's right. We can keep doing this. So 14 divided by 2?
7.
36 divided by 2?
6. Oh, wait, no. That's 6 times 6.
Want to do it here?
No, in my head.
Okay, try it in your head.
13.
Okay. So that's our reduced fraction. Now, if they say reduce it, that's fine. But technically, these are the same answer. Okay, they just have a different ratio. So we've gotten our answers. Okay. These are the same thing, essentially. Same with these two here. So those are dividing fractions. Essentially, you turn a division question into a multiplication question. That's how you solve it. Okay? So now we got our dividing rules up here. So we have our multiplication rules. And just as a quick thing, we'll add a little to it so we know that we multiply it across. Okay? Now, there's multiplying fractions, dividing fractions. Now we're going to add fractions, which is actually, in my opinion, a harder thing to do. Okay? Do you know what you have to do in order to add a fraction? There's something you have to change about them. Do you know? Something about the number on the bottom.
Or make a common denominator.
That's right. We have to get a common denominator. So what we're going to do is we're going to put the multiples of 3 and 7. Okay? Until we get to a common denominator.
21.
Yeah, you're right. 21 is going to be a common denominator. Great. So what would I multiply the first fraction by to get the bottom to be 21? Or what do I multiply?
7.
Yeah, that's right. Multiply this by 7. So whatever you do to the bottom.
Do to the top.
And what about the other fraction?
By 3.
That's right. Good. So now what are we going to get?
14 over 21 plus 15 over 21.
Good. Now, good thing about adding, what's the denominator going to be in the answer?
21.
Yeah, that's right. It's going to be that. Now, the top, we're going to add those two numbers together. Okay? So what are we going to get?
29.
That's right. So our answer is?
29
Over 21. That's it. Simple as that. Since you do this quickly, I don't have to keep that there. Does that make sense?
I totally forgot about
The denominator, right?
denominators.
Okay, so we'll do that as example 1. I'll make one up for you. 2 over 4, 3 over 9. Adding these together. Okay, so what's the first step?
Denominator.
Okay, what's a common denominator? Call it a CD. What's our common denominator going to be?
36.
Good. What do we multiply the first fraction by to get to 36?
9. Oh, I guessed.
What about the second one?
4.
Yeah, good. Alright, so let's go through them. What do we get? 9 times 2 is?
You didn't put the 4.
Oh. 9 times 2 would be what?
18.
Good. divided by?
36.
Good. What about our second one?
12
Mhm.
over 36.
Good. Our answer is going to have a common denominator of
30.
just 30?
Oh, 30 over 36.
Oh, your answer. Oh, good. You added the top. So
Yeah.
30 over 36. Good. That's right. That's exactly what we had to do. Okay? So that's all right. So we put up our adding fractions rule. Finally, subtracting fractions. Well, there's one rule that's going to be the exact same with adding. What did we have to do in adding in order to add them?
We had to get a common denominator.
Yeah. So what's the common denominator here? We already figured it out in our adding question.
21.
That's right. So what do I got to multiply these by in order to?
7 and 3.
Good. Okay. 2 times 7 is?
14.
Mm-hmm. And then 3 times 7?
21.
Good. Subtract.
15.
Mm-hmm. Over.
21.
Mm-hmm. Which is equal to?
1 or negative 1
Good. Over.
21.
Excellent. That's it. That was our example 1. Okay. So it's almost the exact same as adding. We just subtract instead, but we got to get a common denominator. So let's make up another question here for you. 3 over 8 minus 2 over 7. All right. So we need a common denominator. What can we use?
48 or 46. Something
Actually, it's probably going to be whatever 8 times 7 is. Here's a trick. For a common denominator, you can always multiply these by each other,
yeah.
and that will be a common denominator. So 7 times 8,
I thought it was like 46.
56.
It's 56.
Close. Yeah.
And then
So our common denominator here is 56. So what are we going to multiply the first set by? Our first fraction.
7
And the second fraction?
over 8. I mean, times 8.
Times 8. Good. Okay. So 3 times 7?
21.
Good. Divided by?
56.
Good. Subtract?
16.
Mhm.
56.
Good. What's our answer going to be over?
5 over 56.
Good. There we go. We got it. Does that make sense?
Yeah.
So we're going to go over some multiplying and dividing integers. We have our fraction rules up here anyways. Now, multiplying and dividing integers, there's some rules, okay? Do you remember what a positive times a positive is going to be?
Positive.
Yeah, we're going to get a positive number. A negative times a negative?
Is there negative or positive?
It's a positive, good. And then finally, a negative times a positive?
It's a negative.
Yeah. What about vice versa? Positive times a negative?
Same.
Yeah, so it's just the same thing. We don't need to rewrite it because technically you're just using the same rule.
Mm-hmm.
Okay. What about with division? What's a positive divided by a positive?
A positive.
Yeah. Negative divided by negative. Do you know what it's going to be?
Negative. It's a positive.
Yep. And what about a negative divided by a positive and vice versa?
A negative.
Yeah, it's the exact same rules. Okay, so whether we're multiplying or dividing an integer, we get the exact same rules. Okay, so let's say we had, we'll use 9 times 3. Okay, so that's our first example. Example 1. 9 times 3, that's a positive times a positive. We're going to get positive what?
27.
Good. What about negative 9 times negative 3?
27.
Positive or negative?
Positive.
Good. Negative 9 times positive 3?
Negative 27.
Good. And what about negative 3 times positive 9?
Same thing.
Yes. Good. Ready? What about 9 divided by 3?
3.
Negative 9 divided by negative 3? Oops, that's a multiplication sign. No?
Yeah.
What is it?
3.
Positive or negative?
Positive.
Yep. Negative 9 divided by positive 3.
Negative 3.
And 9 divided negative 3.
It's negative.
Good. That's pretty easy, eh?
Yeah.
Multiplying and dividing integers is pretty straightforward. That's a simple topic. Adding and subtracting them is much more difficult. So what we're going to do is just going to, so we've done that. Now adding and subtracting the integers is very different, okay? We could write rules, but the way I want you to remember this is I actually want you to remember them by keeping these in mind, okay? Remember those rules there. We're going to make up some questions. Let's say I do positive 9 plus, not a 9, positive 3. So same values, okay? Plus positive 3. Now, do I need to write this positive in front of that 9?
No.
No, that's not very important. So I'm just going to write it as 9, okay? And same with that 3. Do I need to write it in there?
No.
No. So 9 plus 3, what is that going to give us?
12.
Good. Now what about negative 9 plus, now, negative 3? So this one's a little more confusing, okay? We'll call this example 2.
Negative 12.
Good, good, good. Now, what I want you to do is sometimes this is confusing. See how we have two signs right beside each other?
Mm-hmm.
Just like we did here? We're going to keep these rules in our mind here, okay? Positive times positive is positive, yeah. Negative by a negative is a positive, and then a negative by a positive is a negative, okay? I'm going to keep those rules in mind. What we technically did, if I multiplied positive by a positive, what should I have gotten?
Positive.
So I replaced the two signs with just one positive sign. What about here? My negative 9, so I have two signs. I have a positive and a negative. I want to replace it with just one sign. What's a positive times a negative?
Is a negative.
Yeah, that's right. So I replace, I'm just fixing the other one. I replace the two signs with just one negative sign. Okay, so now I have negative 9 minus 3. That's going to give,
Negative 12.
yeah, which is the exact same as the one above. Okay, what about, we'll say this is example 3, we'll put a little space here. How about negative 9? We did negative 9 plus positive 3. How do I replace that those two positives? What would I replace them with? What sign?
Negative.
What's a positive?
I mean,
times?
positive.
Good. So I just replaced the 2 with 1. So what's negative 9 plus 3?
Sorry?
Negative 9 plus 3. What's that going to be?
Negative 6.
Good. Okay. And example 4. What about 9, positive 9 plus negative 3? Okay.
Negative.
Yeah, we replace those two signs with a negative. Great. So I get 9 minus 3. What's that give us?
6.
6. So, look at, when multiplying and dividing, we repeat answers, right? We would get 2 positive answers and 2 negative answers. And we're dividing 2 positive, 2 negative, right? Kind of that pattern there. When we're adding and subtracting, when we change those numbers up, we get very different answers, okay? I get a positive and a negative in one set, and then a completely different number set of positive and negative, okay? So you got to remember those rules, because all 4 different situations give us different answers, okay? Now we're going to do it with subtracting. This was the adding part of it, okay? That was our adding. Here we'll do the subtracting. Okay, so again, positive 9 minus positive 3. I've got 2 signs there, so what am I going to replace them with? That's example 1. I have a negative and a positive, so what can I replace them with?
A negative.
Good. So 9 minus 3?
Is 6.
Good. Example 2. Negative 9 minus negative 3.
Is positive
Yeah, we replace those two with a positive. So negative 9 plus 3. What's that give us?
Negative 6.
Good. So 3. We have negative 9 minus positive 3. What's that give us?
Negative 3.
So negative 9 minus 3. What's that give us?
Negative 12.
Good. Finally, our last example. Positive 9 minus negative 3. What can we replace those two numbers, or those two signs with?
A positive.
Yep. So 9 plus 3.
Or 12.
Good. So did you see, again, we're going to see the similarities here. Positive 6, right? So the numbers, we end up getting roughly the same numbers throughout. It just depends how they're ordered, okay? So we got the same 4 answers when we're adding and subtracting, okay? They're just in different orders. So we got to remember this little rule. It helps us with our adding and our subtracting of integers. Does that idea make sense? Okay. Okay, so here's your question F on your question. Now, what we want to see is we want to make a letter out of these.
Here it is. It's right here.
Ah, okay, good. So you have rules where they've told you certain types of angles, right? We have a rule where if they make a Z, let's undo that other one. Okay. There's a rule if they make a Z, a rule if they make some form of a C, and a rule if they make like an F. Okay? And what it is they're talking about these angles here. Okay? That, in this one, we'll call this angle A and B. This rule says angle A is equal to angle B when you can make a Z. Okay? When you can make an F, A and B again, angle A and B are equal again. Okay? The one that's different is here, A and B. In this one, angle A plus angle B, do you know what they add up to?
180.
Yeah, they add up to 180. So that's the little trick, okay? So what letter are we making here? Do we end up with an F pattern? Are we looking at these types of angles?
Yeah.
We are. So I have this
No,
angle
we're
down
making a
here.
C.
Ah, that's right. We're looking for a C. Okay?
So it's corresponding.
So we have our C.
That's how you remember.
Yeah. So what are these two angles going to add up to? I'm going to name them, okay? We're going to call that angle A and angle B.
180.
That's right. We know angle A and B are going to add up to 180. So let's write this down. Angle A plus angle B equals 180. So what was the equivalent of angle A? We're going to use this and substitute that value in for angle A. So it says,
So it would be, can we do it like opposite, like 180 equals LA?
all the other way around? It's on the left, 180? Sure. Still the exact same thing. So 180 equals, we're going to replace angle A with that. So we have F minus 32. That's our A. Plus, and what was our B value?
78.
Yeah. So I replaced A with this and B with that. And we'll highlight them, okay, so that you know. Angle A, that's what I replaced angle A with. And angle B, that's what I replaced angle B with. Does that make sense? So now what we're going to do is we're going to use our algebra to solve. 180 is equal to, I'm going to drop the brackets. So I get F minus 32 plus 78. So I need to solve for F. So that means I need to get F all by itself. So what do I want to do here?
You want to do... Okay, wait, negative 32 and 78 together first.
Okay, let's put those together first. So remember, let's go through this. This is 78, negative 32 plus 78. What's that going to be? Want to do it on
46.
Yeah, you're right. Good. We could have done it like this too. Good. So we get F plus or minus 46.
Plus.
Good.
Plus.
Plus 46. Now what do I do? No, I'll do it.
Now.
I'll put this red so you can see. Go ahead.
Now you subtract 46
From what?
from that. From right there
From here?
and there.
Ah, from both sides.
Mm-hmm.
Good. So we take 180, right, plus 46, and we're going to subtract 46 from both sides. That's minus 46. 180 minus 46, what's that going to give us?
Yeah. 134.
Good.
Yes.
And then what happens to the right side here? Positive 46 and negative
So
46.
0. So it's F.
They cancel out, so we're left with that. So what's the value of F?
134.
Boom, done. Does that make sense?
Uh-huh.
Okay, a little different than the answer you had there. Let's do the other one. Okay, question H. What kind of pattern does this make? What letter does it look like?
A C.
Yeah, that's right. We get another C pattern. So what does that mean? What's special about those angles, according to our rules?
They equal up to 180.
Yeah, when we add them together, right? So if we call them A and B again, we'll say 180 is equal to angle A plus angle B. So 180 equals, we replace angle A with this.
Mm-hmm.
So we have 4H minus 56 plus, and we'll replace angle B with this 2H plus 44, right? Now we're going to get rid of the brackets. So 180 is equal to 4H minus 56 plus 2H plus 44. What's the next step?
Now you have to bring everything together.
Yeah, collect like terms. So, what are like terms here?
4H and 2H.
Yeah, 4H and 2H. And what else are like terms?
Negative 56 and 44.
Good. All right, we'll leave the 180 on the left side for now. So when we combine 4H and 2H, what do we get?
6H.
So we get 6H. And when we combine negative 56 plus 44?
Is I don't know.
No, let's try it out. Ready? 56 negative
Sorry.
plus 44 is negative 12.
Good. How many mention?
So, so now that we have this, what do I have to do? I want to get the H by itself. So what do I want to do?
Sorry. You want to add 12 on both sides.
Good. 6H minus 12. We'll add 12 to both sides. Okay. Then what happens?
It's 192.
Is equal to?
6H.
Good. Those cancel out. Then what's our last step?
Divide 6.
Yeah, we want to divide both sides by 6. Right? So
And
192 divided by 6. 32. So what does H equal?
H. 32.
32? Nice. Got it?
Yeah.
Okay.